Good afternoon, ladies and gentlemen, here in Santa Clara, California. Good morning, good afternoon, good evening, wherever you are watching this out there on the World Wide Web. Our next general session, Intel we have now, another huge audience, so let's not cut into any of Jason Waxman's time. He's going to tell us about progressing towards the federated, automated, and client-aware cloud. Take it away, please, Jason. Let's give it up for Jason Waxman.
Well, I'm very pleased to be here today, and I appreciate the strong audience. As a matter of fact, I got to admit something right out of the gate that, sometimes people tell us that Intel isn't exactly synonymous with cloud computing. And one of the benefits, I guess, of being a semiconductor provider and a technology provider is that people know you really, really well for that, but they don't necessarily know you all that well when it comes to some of the broader stuff that you're doing. So what I would just love to do today is be able to share with you some of the things that we're doing to go work very closely with many of you out there already. And if we're not working with you, then we should be working with you to enable cloud computing. If you're here for the speeds and feeds, how many cores, what our roadmap looks like, probably not going to get that today. I'm happy to give you a tutorial after the fact. But what I really do want to do is spend some time to share with you that we are looking to work very closely with you. We are looking to make a difference to really grow this industry, and I want to share with you some of the stuff that we're doing. So with that, let me start with the obligatory big data trends foil. I'm sure you haven't seen any of this stuff before, that cloud is a huge growth opportunity, but I'll hit the facts and I'll hit the highlights for just a second. First of all, in terms of users, we think today there's about 1.5 billion people connected to the internet. We think that by 2015, there'll be roughly another billion people connected, so huge growth there. And as you know, it's not just the standard usage models that we're seeing people address in cloud computing. We're seeing richer content, richer media. I saw a projection today from Ericsson that the growth of mobile internet data is going to be 10x between now in 2016, so huge growth. And the result of that, obviously, is you need to have infrastructure that's going to be able to support all these new usages, new users, new devices, new connectivity that we all have been forecasting and predicting to see. The result of that is that we're expecting the amount of storage connected in cloud computing to grow 6.7 times between now and 2014. And we expect to see that there'll be more than 1,000 exabytes of data connected to the internet based in cloud computing. So the growth is going to be tremendous. And that obviously leads people to be asking, what do we need to do together to go make sure that the infrastructure is in place, that the services are in place, and that we can deal with all of this growth? Well, if you've seen any of our presentations before, one of the things that we've been very consistent with is our view of what we'd like to see the cloud be in 2015. And it really boils down to three relatively simple but consistent elements. The first is around federation of data between data centers. In case you want to know where Intel falls in the there's no such thing as a private cloud to the everything will be a private cloud spectrum, we're sort of what you call moderates, maybe moderate liberals, I'm not sure exactly. But at the end of the day, we think that there will be a hybrid cloud out there, and that to go make sure that that's successful, whether you're deploying your own cloud infrastructure or you're taking advantage of all the different services out there, you're going to want to have federation of those data centers. That's going to require standards, and it's going to require a tremendous amount of security. The second thing that we're very strong on is that there has to be a level of automation that drives efficiency. People are consistently asking, how do I make sure if I deploy a cloud infrastructure that it's just not unwieldy, it's not inefficient. I could easily find myself replacing all of this infrastructure, deploying a whole bunch of things, having consulting services, and at the end of the day, still needing twice as many people as I need today to go manage the infrastructure. Not an equation that we think is successful. So what we want to be able to enable is more automation. How can you go automate and make sure that workloads are placed where they need to be, whether that's in your own data center or whether it's in a service provider type of cloud. And the last element is around what we call client awareness. And the idea behind this, very simple, is that we believe that services should be device appropriate. They should be able to be delivered in a very scalable manner. A number of you who I talk to who are deploying your own cloud services are spending a tremendous amount of time in the infrastructure trying to figure out how to write services once and then allow them to scale across multiple platforms. We have some ideas on that, and I want to share some of them with you in a little bit. So this is basically the focus of the talks. When you heard, federated, automated, and client-aware, it really revolves around the vision that we have, which was really formulated by talking to you folks. There's nothing necessarily breakthrough or revolutionary here. It's just a question of listening to customers, listening to partners, and we're trying to see what we can do and invest Intel's resources to go make this happen. So how do we get there? And I'll break this down into 3 relatively straightforward steps. The first, which we believe very strongly in, is we want to listen to the customer. And I'll contrast this in a little bit, but I think there have been a lot of great efforts put out there in the past, a lot of great efforts that are continuing to move forward to go drive standards and open specifications. We'd like to see those accelerate. The reason being, if we all work together, we lay the foundation, we lay the infrastructure, the market grows, and everyone has opportunity. So start with the user in mind. Nothing necessarily that's a aha moment on it, but it is a core principle to what we're driving. Then the second thing is, once you understand what customers are asking you for, we want to deliver the products and the technologies that become the ingredients that all of you who are solutions providers or vendors or service providers, that they allow you to go innovate and deliver to those usage models. And then the third thing is we want to make it easier to deploy. Too many times, and it may seem like a relatively simple measure, you get through great products, you understand the customer, but it's too hard to go ahead and allow somebody to implement and allow it to scale. And we have a program that we've unveiled. It's really just a partner program that you'll see we've got some great support for, but we'd love to see more of you in it to go just fundamentally make it easier for people to use and to deploy cloud computing. So let's cover each of these 3 in order. I'll start with the user requirements. So I mentioned that a big part of federation that we believe is going to be the usage of open specifications and standards in the industry. And I think there's been some remarkable efforts to date. The thing we want to do is accelerate some of those efforts, and we'd like to go do that by working with the user community to make that happen. Now, at Intel, we have a long commitment to open specifications, and just a couple of examples, we've been instrumental in making sure that peripheral components were standardized and allowing people to go innovate around a common specification, both the I/O vendors as well as the system vendors. We helped to accelerate the promotion of wireless hotspots, to go broaden the wireless industry, which obviously led growth to mobile computing and a whole host of other things. If we didn't work together as an industry to go make that happen, it would have taken 3 years later, based on our estimations, to go achieve the same type of ramp of wireless hotspots. The list goes on. Specifications for manageability, specifications for systems. The idea or the fundamental principle being is that if you make it open, you allow more people to compete. If you allow more people to compete, they innovate, and as a result, the overall share grows. So we've been very, very committed to open specifications, and that is something that is a core to what we'd like to be able to do when it comes to cloud computing. Now, one of the fundamental shifts that we're very excited about is that if you look at the history of many of these open specifications, they've been vendor-driven. And by the way, it's been very successful to go make those things happen. But many of you, I think there's probably a fair number of vendors like Intel out there in the audience today. And you know that every once in a while in these types of bodies, there's a little bit of arm shoving and shifting it in one direction or the other. I really think the thing we ought to embrace is the user-driven specification going forward. And I want to highlight 2 examples that I'll go into more detail on this. The first is with regard to the Open Data Center Alliance, which I'll talk about in just a minute. But it's a group of end user customers that are working on requirements and specifications for open cloud computing. And this is what they are saying is what they want to be able to deploy, what problems they would like to see us as a community go solve. And one of the things that I've noticed in working with that group is that there's a lot less conflict, despite the fact that they come from many, many different industries. The reality is they have a common goal and a common voice about what they're trying to go ahead and solve. And as a result, I think it works quite efficiently. The other thing, which I'll talk about a little bit later on in the talk, is the Open Compute Project and Open Compute Foundation, which we're very pleased to be a part of with Facebook, Rackspace, and a host of others, to go make sure that some of the infrastructure that was really only available to some of the largest hyperscale types of customers can now be available to a much broader base of customers, essentially democratizing that type of infrastructure. So this is a shift, and I hope that many of you will embrace this as well. So let's do a little bit more around the Open Data Center Alliance for just a minute. Intel has what's called a board of advisors where we talk to end users. Even though we don't sell any products or technologies to them, we're always trying to anticipate what their needs are so that we can do a really good job in working with our OEM partners and others to go deliver to those requirements. Well, one of the things that we heard consistently from them about a year ago was that they wanted help in driving their direction in cloud computing. And as a matter of fact, you had many companies around the table who looked at each other and said, you know, we really ought to work together to go make that happen. An idea set off in our head, which is that we should help facilitate this. And we should do it in a way that it's by the end user, it's based on what they want. They're the people who control the votes, who control the organization, and we as Intel would like to facilitate that, but we'll be a technical advisor to it, not someone who votes or steers or writes the specifications that's being driven. Well, I think the group's done a tremendous job. I'm very, very pleased to see what we've helped to facilitate. They now have 4 times the amount of membership in this organization, over 300 major global companies around the world that represent over $100 billion in annual IT spend that is focused towards writing and driving these open specifications for cloud computing. And to just give you an example of some of the things that they are focused on, the boxes that are multicolored down below are some of the problems and some of the working groups that they've collated together. So one of them is around security, and they've helped to set out specifications and requirements for when someone says they are a secure services provider, what does that mean? What's their set of requirements to go differentiate between what someone might call a platinum provider and a silver provider? That when it comes to automation, they'd like to be able to see common systems management across multiple different types of platforms to really simplify that automation problem within their infrastructure, and they're writing a series of requirements to go enable that to happen. As you know, and I'm sure has been the topic of multiple talks today, there's also a tremendously complicated regulatory environment. And one of the things that this group has come together is they're sharing best practices. They're really sharing knowledge with each other about how to deal with the regulatory environment and what might be some of the things that you can do. One of the papers that was published recently, which I think was a very, very high value, and if you haven't seen it, you should seek it out, talks about how to drive resiliency in cloud deployments in the cloud. So there's a lot of best practices sharing, a lot of common interest, and again, the goal being make cloud computing open, make it secure, make it efficient, and have the users specify what it is that they're looking to go do. Now, it is a group, as I mentioned, that has been founded by end users, but at the end of the day, if those of us in the audience today who are vendors or solutions providers don't deliver something to go address those requirements, it's just a bunch of paper. And so what we've helped to do, and this is where Intel, I think, really comes in more strongly, is working with some of the leading companies in the industry to go make sure that there are solutions and there are options being provided to go address those requirements. And I'm very pleased to show in the circle on the left-hand side of this chart that we have many leading companies in the industry who are committed and supported and delivering solutions to go address some of the Open Data Center Alliance usage models. And in fact, just as recently as last week, both CA and HP announced that they're joining and committing to help support the cause. So I appreciate their support, as well as the others who have been involved since the beginning. That momentum now basically leads this organization to have a solution provider tier, not voting members, but a separate category of members designed and committing to help enable this open standards-based vision of cloud computing, is representing 90% of the virtualization market, over 2/3 of the server hardware market, and a tremendous amount of support from the networking, storage, management, and other areas as well. The other element to bringing this together, and one of the reasons that I'm so passionate about how the Open Data Center Alliance can be this center of gravity for bringing together multiple portions, is that there are great work being done today by some of the alliances out there. And so what you see on the right-hand side are some of the announcements for collaboration that the Open Data Center Alliance is working with the CSA, which is the leader in defining cloud security requirements, with Oasis on service provider requirements, as in service delivery, as well as TM Forum for that topic as well. DMTF has done tremendous work in laying the foundation for VM interoperability, and we're very pleased that last week we were able to see an announcement about how OVF will be advanced through a collaboration between the Open Data Center Alliance. And then also Open Compute announced that they would be sharing and helping to get Open Data Center Alliance feedback into their hardware specifications as well. So a lot of great interest in really tapping into this voice of the customer. And I'm very pleased that today we're going to be announcing that that we are collaborating with the Green Grid to yet address one more major problem in the industry. I'd like to have you help me welcome Mukesh Katar from Oracle and the Green Grid.
Thank you very much, Jason. I'm here from the Green Grid, representing them today to welcome this collaboration we have with Open Data Center Compute. This is a great alliance. The Green Grid is basically a collaboration of IT manufacturers, the IT users, the infrastructure manufacturers, and government agencies, academicians. We are basically working together to come up with standards so to improve the energy efficiency and resource compute efficiency of our data centers and business ecosystems of IT equipment. So we are very pleased to have this collaboration, and I'm sure we are going to be working on in the next few days or next few months on developing methodologies for consistently reporting on the carbon usage effectiveness, energy efficiency in the data center space. Thank you.
Great, thank you. So going back to the regulatory environment, one of the things we heard, particularly from some of our end users in the Open Data Center Alliance in Australia and in Europe, is that it's not just enough to be carbon neutral within your own data center. It's a huge challenge to figure out whether you're carbon neutral when you're working across multiple service providers. So some of this work that we see the Green Grid doing in combination with the Open Data Center Alliance, we think is going to help provide some of those requirements, provide some of the standards out there in the industry. And if we can do that, again, it means more people feel comfortable about how they use and they can use cloud computing services, and we hopefully move the market and the industry grows. So again, looking forward to the results from that. One of the things that we then asked the Open Data Center Alliance is, what are your biggest problems and biggest challenges? And so this group of 300 members, companies, came back with their answers to it, and I don't think that these will surprise you. The two biggest elements that they were concerned about are how to go develop a reasonable application migration strategy, again, spanning what they'd like to see done in their own infrastructure and their own clouds, and as well as the service providers, and then how do you meaningfully address the requirements around security, around secure multi-tenancy, or knowing what types of controls a service provider has, so there's that level of transparency and they know what they can comfortably move into a cloud service provider data center. So what, again, we as a community want to be able to do is work together to see how we can come up with usage models or policies or applications or solutions to go address these types of requirements. So I talked a little bit about listening to the end user. I now want to shift gears and talk a little bit about what are some of the fundamental products and technologies. And I don't want you to think that this is a roadmap presentation. What I want to highlight, mostly through examples of our partners as to what creative companies are doing to go address these challenges using some of the initial ingredients that we're providing. So I'm going to focus in on three areas around the technology. The first is around secure cloud infrastructure. How can we make it easier for someone who wants to use cloud services or is looking at deploying their own cloud services to address some of their concerns around multi-tenancy and how and where their data is managed from a federation perspective. Second, how do we make it more efficient to go manage our resources? We've estimated that if you look at the growth of cloud computing and it's not done efficiently, the sheer size of that infrastructure could consume as many as 45 new coal power plants. That is a huge global impact aside from the individual cost that companies are concerned about. So we want to look at how there can be technologies looking from the smallest elements all the way up to the highest levels of the data center to go make sure that the infrastructure is efficient and people are deploying cloud infrastructure in the most efficient means possible. And then last, I want to talk a little bit about client-aware clouds and some of the new applications that I'm excited about. I want to share with you, and I think these represent a huge untapped potential for those of you that are developing your businesses. And of course, as Intel, we want to work with all of you in deploying these technologies. So I want to start with security for a moment. As I mentioned, the biggest concern that we continue to see that you saw from the Open Data Center Alliance, and I'm sure has been present in every analyst report that you've seen, every customer conversation that you have, they are concerned about security. It is the #1 barrier today in terms of people moving to cloud computing. So where do we start? And by the way, it's an ongoing process. It's not something that's going to be perfected overnight, but there are some things that we can do. The first thing we want to be able to do is look for ways to be able to isolate and ensure compliance within the cloud infrastructure itself. And so some of the technologies that we've been working to go off and enable, such as our trusted execution technology, represent a very small step forward, but when combined with trusted solutions and security solutions, really can provide for a hardware-based root of trust. The way it works is very simple. People are concerned that some set of malware or a rootkit or a backdoor essentially could compromise the security of a platform. So how do you make sure that when you're deploying thousands of servers that that root of trust in those servers is done in a meaningful way? We provide a secure place, a secure platform module on the platform itself to allow you and to deploy your solution such that as you bring up those systems, you have a known root of trust. And if you reboot those systems, you have the ability to compare to see whether something has been modified in the underlying infrastructure. And that then allows you to do a couple of different things. One is to be able to isolate, again, to make it more difficult for somebody who wants to tunnel from one platform to, one virtual machine to the next on the same platform to make it more difficult for them. And second, to flag something if something has been modified upon a reboot. The other element that we'd like to be able to address is that we're more and more continuing to see the need for real-time encryption or to be able to encrypt more data. That obviously requires more compute capability, and we want to be able to provide ingredients that allow people who are deploying solutions that need to be secure, that need that level of broad encryption to be done in a cost-effective and a high-performance type of manner. So I mentioned that I would focus in more on what people are doing with it, and I'm very excited to see that, number one, NIST has come out, tried these technologies, and said that they see a benefit and they like the ability to be able to offer to other government agencies this as a good first step in providing secure isolation and a hardware-based root of trust to the platform. But we also see other platform service providers supporting these types of technologies. Terramark has come out and said they're supporting it, offering it to their customers, VirtuStream, Expedient. And so the key thing is that if you are a service provider out there and you're looking to address some of these usage model requirements that you see coming from customers, and you'd like to talk about how we can help work together to provide technology ingredients that might make the platform more secure so that you can offer these types of services to your customer, a secure VM, a secure root of trust, we'd like to be able to help out there. But that's really just part of the beginning. And one exciting new product announcement that we do have today is that you've been aware for quite some time that we've been working through some of the technology integration between McAfee and Intel. They've been working on cloud security from a platform perspective, and this goes really beyond just the infrastructure of the platform, but to really focus in on how do you manage your services, how do you federate across multiple data centers. And what they've announced today, and there'll be more, I think, talking about the ins and outs of the product a little bit more tomorrow, I'll leave it to them, is they're talking about how to go ahead and do a better job of data loss prevention by doing a better job of data classification. So what kinds of data are you dealing with and what kinds of policies should you set through this? So new tools and applications for that. To look at email security and broader encryption across multiple different types of platforms that you can secure. that data within an email in flight, and then also look at broad federation of services. So we're excited about this platform. If you're interested in seeing more about it, I believe you can go check it out at the booth, but also stay tuned. I know McAfee will be talking more about it tomorrow. And this is really, in my opinion, the tip of the iceberg. We want to look at how we, through the assets of McAfee and the hardware-based capabilities that we can put into the platform, can really make the foundation for cloud computing much more secure, and as a result, provide a foundation for secure services or how you deploy cloud computing. So shifting gears from security to talking about the security infrastructure, the efficiency of the infrastructure. One of the things I wanted to highlight, and there have been a lot of people who've shown similar sorts of pie charts, they all are roughly consistent, is that when you get to a cloud infrastructure, and for those of you who are deploying a cloud set of services, either as a service provider or within your own enterprise data centers, when you get to a high level of efficiency, this is roughly what your total cost of ownership is going to look like. And by the way, even within our own Intel IT, on the scale sites of services that we have, it tends to look like this more often than not. So what we find is that about half the cost of the infrastructure is the cost of the equipment, and about another quarter, roughly, is the cost of power. And so what we've been doing to work with companies, again, way beyond the silicon, we've really developed a approach to looking at how we can analyze everything. And I would encourage you who are deploying your cloud services to start by looking at the software and looking at how you can get more scale or tuning out of it. I know there's a belief in cloud computing that it makes it easy, since you've got scale, for the programmers to use, say, poor programming capabilities, because you just get things to scale and it's relatively cheap and you just throw more hardware at it. And that certainly works up until a point. And then at another point, you start to realize that you have all this infrastructure that's being used inefficiently. If you have 10,000 servers and you get 10% performance efficiency by tuning that code, just 10%, and by the way, the numbers could be a heck of a lot better than that, you saved 1,000 servers, and if you figure each server is worth about $3,000, that's $3 million in savings just by implementing some better practices. So looking at the code is one of the first places that we start. And then from there, we look at what types of platform technologies or capabilities might best run that type of application. I'll say a bit more about that in a minute. And then what types of platforms or types of infrastructure could be deployed, and how to do that in the most efficient means possible. And then look at the data center. And again, I want to share with you some of the things that I've seen companies do and how they've been successful in treating this cloud infrastructure as a closed-loop system, looking at all of the components, all the elements of the system to address that 75% of the total cost of ownership, which relates back to the cost of the equipment and the cost of the power. So the first element that I mentioned is around the workloads themselves. And from my perspective, I see three categories emerging. I think there's a mainstream type of category for cloud workloads. Some of them, for example, might be search engines or search applications where there's a high degree of performance, there's a high priority put on latency, so you need a degree of performance, but we tend to see these be general purpose, two-socket types of platforms that still need a sizable amount of memory, a sizable amount of performance in those types of applications. There is another class that we see emerging, which revolves around visualization or highly parallel types of workloads, where it may be a scientific type of workload. Some of you are deploying high-performance computing types of applications in a cloud infrastructure and environment. And the thing that I want to highlight is that you absolutely can, and a lot of people do, try and take a one-size-fits-all approach, where I will deploy one general-purpose server and it will take across all these different types of applications. It's certainly very effective and efficient to manage. It is not very efficient from a total cost of ownership perspective. When you're talking about the types of applications that fall into that middle category being accelerated by some of the technologies we have down the line that may have as many as 50 cores, there's going to be a bigger disparity. So one of the things that we're encouraging people to look at today is classifying and categorizing your workloads and trying to figure out what the architectural strategy will be for the infrastructure if you're doing it on a large-scale type of environment. And then to make matters even more complicated, there's yet another category of applications that are focused on lightweight workloads, web tier types of applications. Some people might classify Hadoop into this type of category of very highly distributed types of applications where the nodes themselves could be very lightweight. So what we'd like to be able to do is make sure that there's a wide range of different platforms out there. You won't see us offering those systems, but we're going to go work with the broad industry to make sure that whatever the right infrastructure it is that you're looking for, whatever the application category is, that there's a tuned infrastructure that's available and highly efficient to deploy. And second, we want to work with the people that are doing the provisioning layer to make sure that you can handle these types of heterogeneous types of environments and the right workloads find themselves to the right types of platforms. This is what we need to do for an efficiency perspective. So one of the elements in making that happen that we're very pleased to be a part of is the Open Compute project. And I used an analogy for those of you that weren't at the Open Compute Summit last week in New York. I used an analogy of cars or automobiles. It used to be that you could get whatever type of server you wanted as long as it was 2 sockets, it was 4 DIMMs, and had 3 PCI slots, or maybe even PCIe slots, depending upon the time frame you were looking at. The net is, it was a lot like the Model T, that you could get only those sorts of things because it was done for a mass production type of environment. What cloud computing changes is the level of scale and the importance of hyperscale in the environment. And so what we want to do through Open Compute, through our partners with Facebook and Rackspace and others who are involved in the project, is really be able to bring the economics of scale computing to the masses. Now, one thing which I used in my analogy is that this does not mean that everyone should go out and build their own kit car, because I know that people have followed that the likes of Facebook and maybe some others in that hyperscale type of environment are rolling their own servers and building it themselves. They obviously are very highly capable, and at that type of economics, it might make scale. But for the vast majority of folks, the real benefit in Open Compute is that the IP will be open. People will be able to get access to these highly optimized types of systems, but they'll get it through their traditional channels, and they'll get the support, the supply chain management, the integration, and the other types of services that they need. So from my perspective, Open Compute is great from an efficiency perspective. It's great in that it's really democratizing the access to these types of platforms, but it does not mean go out and start your own server design shop within your data center. Some people it may make sense for, but a lot of folks, they'll do their best by working with their partners to make that happen. So again, very exciting to really bring this type of efficiency to the masses. The other element that we are looking at is really how we take a holistic approach to platform optimization. And I won't really dwell on this too much except to say that everything is connected and tied. When you look at the low-level gates and the process technology that needs efficiency, to how people implement silicon manufacturing in a package, to how those semiconductors get packaged together into a system, to how the boards and the systems themselves are laid out, to how they're packaged into a rack, to how power is distributed across the data center. All of these things are tied, and by working with organizations such as the Green Grid, by working with smart vendors in the community, by working with the standards organizations and others who want to innovate here, we want to take what we call a approach to optimization that's from gate to grid, from the smallest components all the way to the largest components. We think there's a lot that can be done to go take as much power as we can out of the infrastructure and make it as efficient as possible. And again, for those of you who that's your focus, we'd love to be working with you on that. So let's assume you have the most efficient platforms. There is the element of power management. And if you're looking at trying to automate the management of those data centers in the most efficient ways possible, you need to be able to do data center level power management. So a couple of examples of things that we've been working with companies to go do. The first is power and thermal monitoring. How can you at scale, when you're deploying thousands of servers, and by the way, many of these companies are already doing this at scale with thousands of servers, look from a software perspective rather than having specialized hardware to do power and thermal sensing. And as a result, to be able to go drive a power capping technology. You may not want, for example, for density reasons, to be able to have a rack exceed a certain power envelope. You may want to be able to provide a policy-based power management scheme to say these workloads are SLA critical and these other ones may not. The only way you can do that effectively and with the right types of latency is by deploying a policy-based power management scheme and by doing workload power optimization. And you can see some of the results that these companies have achieved. The other element is that it's also nice to be able to say, in the event that you do have some sort of failure and you're moving to UPS, or that you want to extend the life of your UPS based off of some sort of data center event, to be able to have a policy so that on a large scale you could take the servers and allow them to throttle down, giving you more life without necessarily impacting the service level agreement. So there's a great opportunity, again, to look at some of the case studies that have been published, the reference examples, and if you are deploying your own data center or you're a service provider, this is an area we'd love to be able to share what other people are doing in the industry. I also wanted to share some of our research in data center optimization. It's not necessarily all that well known that Intel has spent time focusing in on the temperatures of the data centers as well. As a matter of fact, in our own New Mexico data center, of which this is an example, we have for quite some time been running in a higher ambient temperature environment. Now, I wish I could say that it's as simple as you just open up the windows and you let the hot air come in and you just let it go. Doesn't necessarily work quite that well, although in some cases, believe it or not, it's not that far from where we've been. But the reality is if you run the data center hotter, it doesn't mean that the data center is more efficient. Now, yes, you will save on the chillers. Yes, you might save on the cost of that infrastructure, but at the end of the day, that temperature actually has some unintended effects at the system level. The thermal resistivity may be up, and you may actually lose ground by running the temperature of the data center too hot. So you have to, again, take that holistic data center optimization approach. What we're showing here is that if you can run efficiently at a data center level, that you could increase your compute capability by 7%. So you just want to put more servers into that existing infrastructure, you can get more headroom by running with a high ambient temperature type of environment. If you want to decrease the cooling costs, the savings could be substantial. If you don't need any more infrastructure, you could save about $3 million per year in cooling costs. And this is, by the way, assuming a 15 megawatt type of infrastructure, so scale your numbers appropriately. Or you could say, if you're building a new facility, I'm going to design with high ambient temperature in mind, and I'm going to save $22 million in CapEx cost. All of these things are achievable, but they're not necessarily easy. And again, it's an area where we as a community, the more we can share our best practices, the more we can work through things such as the Green Grid or the Open Data Center Alliance, and we at Intel are trying to publish our papers in these areas as well. We can share how people can drive data center efficiency. So we covered security. We talked about the efficiency of the infrastructure, looking holistically at both workload scheduling, power management, performance, and right-sizing the infrastructure. I now want to talk a little bit about what we call the client-aware cloud. And the element behind this is simple. The two-way arrows are that we want the clients themselves to expose the capabilities of what they have, what types of context or content or capability that they've got. Do you have a large screen size, a small screen size? What kinds of levels of security do you have? Where are you on the network? The more you can expose those types of capabilities, the more that we can design cloud content and cloud infrastructure that scales across those types of capabilities. And we've got a number of case studies, again, where we can share what people are doing, but this is a very exciting thing for us. Just to give one example, we worked with Res Software to look at a virtual desktop type of model where if you had a certain amount of client capabilities, if you ran, for example, in a thin client environment, you did everything in the data center. If you had a richer client, you could actually offload without even the user knowing it. You could offload some of the HTML5 frame rate rendering capabilities to that client, and as a result, get a 5x performance speed up and use less of the resources within the data center. So there's meaningful benefit to architecting these things. I know that many of you may be coming up with your own set of presentation services for how to go ahead and get the services that you're designing with your environment to scale across these environments. It's certainly something that we advocate. And again, one tool that I want to offer up here, not a product, is just a tool called the Intel Web APIs, where the idea behind it is it's something that can be installed on a range of different clients that then expose through either a browser or a platform type of capability what the capabilities are of the device and allowing you to have more insight to how to architect your services. And I want to use a specific example to illustrate this. This is some work that we did with Lenovo and Stoneware to go help them to optimize their client-aware cloud services. And this is a very exciting capability from my perspective. There's a technology called identification protection technology, where the idea simply behind it is take those secure ID tokens and essentially allow a service provider to embed that into the platform. That then becomes the basis for multi-factor authentication to a service provider or within an IT environment. If those of you that are IT professionals who are here in the audience today, I know one of the things that people have told me they're struggling with is how do I enable this consumerization of IT and really allow people to be flexible, because I want them to be flexible, but at the same time not compromise the security of my environment. It's this type of capability with multi-factor authentication that then allows you to architect services, set permissions, and really increase the capability and the awareness of what can be delivered to those devices. This is a real-world example, and in fact, I think Stoneware is down at the show floor, and I encourage you to go reach out to them and see what it is that they have and how they've implemented it, because again, this is exciting technology. But there's one thing that I want to hopefully get you to open up about, which is today, most of the devices, when you think about clients, you think about devices, maybe you think about smartphones, or you're thinking about PCs. You're thinking about the types of devices that a user has on their lap, in their hand, and is actively reaching out to get technology. That represents about 4 billion devices. The other 11 are going to be the types of platforms that a lot of people aren't necessarily architecting for today. They used to be called embedded, but embedded's too dumb sounding. It's really about intelligent connected solutions. And we have a very, very simple vision, which is that if it consumes power, it could do computing. And if it can do computing, it can be connected. And we'd like to see a wide range of these types of platforms, whether it's in-vehicle infotainment, whether it's factory automation, where cameras, for example, can be looking for defects in real time and communicating and doing real-time analysis of that factory automation, whether it's the smart grid or retail applications. We think this represents a tremendous opportunity for those of you who are developing solutions to really take the client-aware cloud to the next level. And I want to illustrate this with an example, which is that in Willowbrook, New Jersey right now, we're rolling out this beauty spot in the Macy's there, where someone can come up, actually have the camera take a picture of their face, and they can go ahead and try on different types of lipstick. And you obviously can think about how, by the way, I'm looking around the audience, I can tell this is definitely not the right demographic for this example. I'm going to try this at a different place, or maybe I'll come up with a different, Legos. Think Legos. Is that better? But actually, in this particular example, you can think of the possibilities of not just making a greater consumer experience, but how can you in real time try out what products might sell, tie this in with your supply chain, and really take efficiency and the business value to a whole new level. It's not just about the devices that you access, it's the devices that will be around us in the next several years, and I'm very excited about this possibility. So, bringing it back to action, talked about the user requirements and listening to the users, talked about security, talked about the efficiency and the automation requirements around the cloud, and how we can go from a technology perspective, make client-aware cloud a reality. How do we go make it easier for people to deploy? And this is where a program that we've put into place called the Intel Cloud Builders Program comes into play. This is not a system integration play. This is not a consulting play. Our mission is very, very simple here. We just want to make it easier for people to deploy your solutions. And you can see this is already a veritable who's who of the industry coming up with not fluffy white papers, not product demos, though by the way, those are all great too, but these are proven reference architectures that if someone says, I want to do that, how can they deploy it? What's an architecture that's not just good on paper, but has actually been tested and proven to work in the industry? And you can see some of the categories and examples that we have here around security, around how to make it easier for companies to deploy their own infrastructure as a service, to go drive efficiency in deploying the cloud, and even some of the client-aware cloud examples. There are 50 of them published. I would love to publish much more, and I hope that some of you out there today who have your solutions, who are trying to figure out how to go make it easier, that we might be able to work together to bring and add your solutions to this list as well. And by the way, obviously, if you're a user out there, I would love to see you give us feedback on how useful these things are or what additional requirements we might want to go drive reference architectures around. This is just highlighting a couple more of the examples out there. You can see that we've worked with Citrix to look at VM onboarding and interoperability. We have a reference architecture from VMware around unified fabric and how you can deploy a simpler network infrastructure using their products in the environment. How we've worked with Dell and some of their partners to focus in on the efficiency elements. How can you manage the power efficiency at scale within cloud computing? Parallels highlighted the trusted virtual machine technology that we talked about earlier. EMC has a reference architecture on there for cloud secure onboarding and ensuring compliance with the service provider environment. And Red Hat focused in on cloud interoperability. Regardless of the examples, they're all very powerful ones, and most importantly, they're allowing people to get meaningful work done. I wanted to quickly highlight one more example, and this is the Nexenta store. It's a distributed object store type of environment where what you see is there's two locations here, and our goal has been to work with them to optimize that infrastructure to make it more efficient by using real-time inline deduplication and compression. They're taking advantage of that encryption, which becomes so important, that encryption acceleration that I talked about earlier, and we've been working with them to go help make sure that the caching infrastructure is scalable in the environment. So this architecture is up there. If you haven't seen it, I encourage you to go take a look at that as well. It either serves as a great example for you as an end user looking to do a redundant or a distributed object store, or potentially if you're looking for an example of how you might deploy your own reference architectures. I think, again, it's a new and a great example. So let me just summarize then. We're committed to making this vision of a cloud 2015 happen with federated, automated, and client-aware. And I hope when you think of clients in the future that you'll certainly think about how to deliver services for mobile and for PC computing types of environments, but you'll also think about that much broader context of these intelligent and connected solutions. Our strategy is simple, and I hope that you'll join us. We want to listen and support and advocate for the user requirements. And if you're interested in joining the Open Data Center Alliance or Open Compute, the websites are up there. We would love to work with you to enable new products and technologies in secure computing, in efficient computing, and in client-aware technologies. And we just want to make it easier for those of you that are building or deploying products to get them out there in the industry. And you can see the website for cloud builders up there as well. And last, feel free to follow me on Twitter or connect. We would love to be doing more with more of you in the audience. So I want to thank you for your time. This was my pleasure to have an audience like this for an Intel presentation in cloud. So thank you.